Welcome to Science with Mr. Weber. Today we'll be looking at the empirical formula. The empirical formula is a formula that represents the simplest whole number ratio of the atoms within a compound. So let's have a look at our example here. So we've got glucose, which has the compound C6H12O6, and now the empirical formula is just looking at the ratio of each of these atoms, okay? So if we make, so just going to find, so it's basically 1 to 2 to 1, okay? That's our ratio. So the empirical formula for glucose ends up being CH2O. Now that does not represent how many atoms are actually there in reality, but you'll see how this is a handy way, if you're given limited information, that you could end up working out what the molecular formula is from the empirical formula. So, well, let's have a go. So, determining empirical formula. So, a compound was analyzed and found to contain 13.5 grams of calcium, 10.8 grams of oxygen, and 0.675 grams of hydrogen. Okay, so what is the empirical formula of the compound? So in order to work this out, we actually need to find out the number of moles that are actually present for each element. So the formula we're going to use is N equals the mass of the sample over the molar mass of the element. So let's have a look at calcium. So the number of moles of calcium will be equal to, so it'll be N is equal to, so the mass of the sample, which is given, so 13.5 grams divided by the molar mass of calcium. So have a look at your periodic table, and that is 40.1 grams. And so we're going to calculate that, and we end up getting 0.337 moles. Okay, let's do the same for our oxygen. So for oxygen, we've got a mass of 10.8 grams. That's our mass of sample. The molar mass of oxygen is 16.00. And so the number of moles that we'll end up with is around 0.675 moles. And finally, for our hydrogen, we've got 0.675 grams, and the molar mass of hydrogen is 1.008. Okay, so the number of moles is also 0.675. Okay, so now what we need to do is we need to work out what the ratio of these elements is. Okay, so what we're going to do is we're going to take the smallest number of moles and we're going to divide everything else by that. Okay, so let's just write this up as, okay, so the ratio of calcium to, oxygen to hydrogen. And so the number of moles of calcium that we had was 0.337, okay, to 0.675 to 0.675. Now we're going to divide by 0.337, and we end up with 1, 2, and 2. Okay, so this here is our ratio of the elements in the compound. So let's have a go at putting together the empirical formula. So we'll end up with CaO2H2. Okay, now you could leave it there, but this is year 11 chemistry, and remember we are meant to be learning some of these ions by heart. And O2H2 doesn't really make sense, but having 2 lots of hydroxide ion, that makes a lot more sense. So let's go ahead and draw that in. So we'd end up with CaOH brackets, because it's a polyatomic ion, and 2 lots of that. That, to me, is the most correct answer that you could get from this. Okay, and that's just by working out the number of moles and then trying to find the simplest whole number ratio of those moles and applying it inside an equation. Okay, and alright, so determining the molecular formula from the empirical formula. Okay, so the empirical formula of hexane is C3H7. Its molecular weight is 86.2 atomic mass units. What is the molecular formula of hexane? Alright, so the first thing that we want to do is we want to work out, okay, how much does so for C3H7, let's actually just find out what the mass of the empirical formula is. Okay, so the mass of carbon is 12.01, so that's carbon. Okay, and we've got 3 lots of it. We're going to go times 3. Okay, which will give us about 36.03. And for our hydrogen, we're going to go 1.008, again, getting this from the periodic table. And we've got 7 lots. Okay, will give us 7.056. Okay, to give us a total of 43.09. Okay, so that's the your empirical formula mass. Now we were told that the molecular mass was 86.2. Okay, so what we want to go ahead and do is we want to go, alright, well, what's the ratio between these two? So we're going to go molecular divided by empirical to give us our ratio. Okay, so we're going to go 86.2 divided by 43.09, and we end up with approximately 2. Okay, now what that indicates is that the molecular mass is 2 times that of the empirical formula, meaning that we need to multiply our empirical formula, let's write that up, our empirical formula by 2, okay, because that's our scale factor there. So we're going to go ahead and do that. So the molecular formula for hexane must be C6H14. Okay, and then if you really want to double check, you could go ahead and do 6 times 12.01 plus 14 times 1.008, and we do end up with 86.2. Alright, now that's a good video to explain that and further practice. So the limiting reagent. The limiting reagent, so that's just the reactant in a chemical reaction that limits the amount of product that can be formed. Okay, so when you have 2 things reacting, they're going to react completely. So if you have a larger amount of one chemical and a smaller amount of another, you're going to have the smaller amount finishing reacting, and there's nothing left for the other one to react with. So let's have a look at our example of sausages, buns, and hot dogs here. So we have 1, 2, 3, 4, 5 sausages, and we've got 1, 2, 3, 4 buns. Okay, so if we're going to make hot dogs out of these, we can only make 4 hot dogs because we do not have enough buns. Okay, so the limiting reagent, or the thing that's going to determine exactly how much product you can produce, so your theoretical yield, is actually going to come down to your hot dog buns. Okay, and your excess reagent is going to be the sausages. Okay, and that's going to be left remaining even after the reaction's all finished because there hasn't been enough buns to react that out. Okay, guys. That's it from me today. Thanks for watching. I'll see you next time.